Welcome all to the lab of computer networks. The code is BCS 502, presented by Madhu Nagraj, Assistant Professor, Department of CSE Data Science. So the first program is implement a 3 nodes point-to-point network with duplex links between them. Set the queue size, vary the bandwidth, and find the number of packets dropped. So here mainly we are going to set up a network where we will be having a 3 nodes and each node will be connected point to point where we are going to use the duplex link between them. So what is the duplex link? So duplex link means where we can send and receive the data in the same link. So in the both the ways, we can send and receive the data. So that is what is called as duplex. And then we are going to set the queue size and we are going to find out how many packets were dropped once the data is transferred. So before going into the program, let us see what is NS2 and how we are going to perform this simulation and how we are going to track the packets when it is dropped. So for that, we are going to use the tool called as NS2. So it is an open source tool which is mainly used for simulation and we run it on the Linux. So here the simulator mainly checks, or this is mainly used to find out the simulation of the routings, how we are going to use the different protocols, the multicast protocols, the IP protocols. So mainly we are going to use or check with the UDP, that is user datagram protocol, as well as the TCP, that is the transfer control protocol. And also here, it is a simulation tool and mainly used for the communication networks. So here the simulation of wired as well as the wireless network functions are used. So mainly with the help of this NS2. So it is the open structure. So here this is the basic architecture of the NS2 where we are going to have the simulation script which is inserted. So here it undergoes the shell commands and here we use it in the TCL language, tool command language. And then it will be going to have the simulation where we have a file called as the trace file where it is going to trace the entire data or the entire process which happens in the program. So it is like a log file that is called as a trace file. And then it will be having the two parts in the trace file. One is the NAM file, that is the animation file, network animation, and then the graph plotting if we require, so that can be done. So this is the structure of the NS2. So what is this TCL? That is the tool command language. So it is mainly used as a scripting language. So where it runs both on the Linux, Windows as well as the Mac platforms. And also it is mainly used to declare the different data types, the variables. So whatever we use in the simulation programs. So in order to use that, we make use of the TCL. And here mainly we make use of the dollar command. So which treats as the starting of any of the command. So once we finds the dollar and whichever the letters follows that, the letters or digits, so that means it is a variable name. So here we can use the command called as open in order to open the files. So let's check with the program. So this is the first program, the simulator program. So so set ns new simulator. So ns, so this is a object of the class simulator. So we are creating the object called as ns of the class simulator with the help of the keyword new. Next, I'm opening a trace file as well as a NAM file. So that trace file is used to trace the data of the program. So it is like a log file. And NAM file, it is mainly used for the network animation. So I'm setting or I'm opening program1.tr. So that is a trace file as well as program1.nam. That is the network animation file. So two files are created. Next. So this is the finished procedure. We will come here at the last. We'll check with the next function. So here, first I'm creating 3 nodes. So as the program statement suggests or indicates, 3 nodes are created. So set N0, N1 and N2. So these are the 3 nodes which I'm creating. Then I'm labeling the first node as the TCP source and the last node as the sink. Sink means the destination source. So one node, the first node is treated as the source node and the last node is treated as the destination node. And I'm giving the color between the nodes. So color blue. Now I'm creating the link between three nodes. So duplex link is created from N0 to N1. So where it is having the capacity of 1 MB and there is a delay between of 10 milliseconds, and drop tail means so where it can drop the extra packet. So we are using the drop tail, and one more link between N1 and N2 is created with the same properties. Now I'm creating the orientation. That means next to which node has to be created. So I have to check the orientation. So I'm creating the orientation. So duplex link created between N0 and N1. So I'm placing N1 to the right of N0. So orient right. Next I'm placing N2 to the right of N1, that is orient right. So two nodes are created. Next, set queue size. So now we can modify the queue length so that we can check how many nodes are created and how many nodes are dropped or how many packets are created. So for that we have the varying queue length. So queue limit for between N0 and N1 is 10 and N1 and N2. So two queues are created. So 10 is set for both the queues. Next, I'm using the TCP agent. So here we are using the TCP connection. So TCP is a subclass of class agent. So I'm creating an object called as TCP0, which is under the class TCP, which is a subclass of the class agent. With the help of the new, I'm creating this object. Next, I'm attaching this TCP0 to the first node, that is N0. And then I'm creating one more object called as sync0 of the class TCP sync, which is a subclass of the class agent. And I'm attaching that to the destination node called as the sync node. So sync0 and N2. So I'm attaching these two. So once this is done, I'm connecting TCP0 and sync0. That is the first node and the last node. I'm connecting these two. Now I'm setting the application layer traffic. So CBR is a subclass under the application layer. So application traffic CBR, and I'm creating the object of that called as CBR0. Next, the type which we are using is CBR, and then the packet size is 100. Rate at which it has to be sent is 1 MB. So we are not going to use any random file. So I'm setting random as false. And finally, we are attaching agent to TCP0. Now I'm setting class 1 to TCP0. That means we are using the blue color. So that is why class 1 is used. Next, I'm scheduling the events. At point 0, the CBR is going to start. That is at the bit rate, cyclic bit rate, it is going to start. So CBR 0. And at the time 5, we are going to finish it. So start at 0 and finish it at 5. And after this, we are going to execute the finish function. So proc finish. So this is the procedure finish, the function name finish. Then we are using trace file and the nam file. So flush trace means, so once all the execution is done, clear everything. So flush trace. Close the trace file, close the nam file, and then execute the animation file, that is program1 nam. So after the trace file is executed, execute the nam file, then check the number of packets that is dropped. So how you are going to check it? So by using the echo command, I'm going to trace the number of packets that is dropped. So the number of packets dropped is, then use the grep command to count the number of packets. So minus C cap D, that is in the trace file, wherever you find the cap D symbol, that means all those files are dropped. So from the trace file, you're going to check for this symbol and exit 0. So once you execute this file, so then we are going to find the result. So how to check for the result? So we are going to go to gedit and type the name of the program. Then run the simulation program. Then we will get the output as the number of packet dropped is -5. So this is the animation where we are going to find. So these are the packets that are going. So 1 to 2, so you can find it anywhere which you want. So from 1 to 0, 1 and 2. So the packets are going to drop. So this is the program 1 where we are going to find out about the animation files. Thank you.